Start new chapter, liquid state. Okay, we have studied there are three states of matter. Okay, in 11th standard also you have studied states of matter: solid, liquid and gaseous. Okay, solid state we have studied in 12th standard, right? So here we are going to study liquid state. Okay, we know that liquid state is the intermediate state between solid state and gaseous state. Understand? It is middle state, solid and gaseous state. Okay, when solids are heated they converts into liquid, and when liquids are further heated they vaporize into gaseous form. Okay, so liquid state is the intermediate state between gaseous state and solid state. Okay, and we have studied that solids have definite arrangement of atoms, ions. Okay, and compact arrangement is there, means constituent particles are arranged very close to each other. When solids are converted into liquid, what is the state in liquid? In liquid, the molecules they are little away from each other as compared to solid. Okay, they are not very close to each other. Then in gaseous state they are more, means distance between two molecules is more than that is found in liquid state. Okay, so there are some characteristic properties of liquid state. Let us see what are the properties of liquid state. So you can see here characteristic properties of liquid state. See, first property, the liquid is made up of molecules, atoms in rare cases. Okay, what does it means? Liquids are mainly made up of molecules, and in some rare cases these liquids are made up of atoms. Example of this rare case is mercury. Okay, liquid of mercury is made up of atoms and not molecules. Okay, atoms of mercury come together and the liquid is formed, but in most of the cases liquid is made up of molecules. For example, if you take water, water is made up of H2O molecules. Okay, so this was the first characteristic. Second point is intermolecular forces of attraction in liquid are quite large. As a result, the molecules of liquids are quite close to each other. Okay, and this is as compared to gaseous state. If we compare liquid state to gaseous state, we will find that intermolecular forces of attraction in between two molecules are large. Okay, and that's why these molecules of liquid are quite close to each other. Understand? As compared to gaseous state. And then third point, the molecules of liquid are in a state of constant random rapid motion. Okay, they are not compact or they are not very close to each other. Okay, and that's why these molecules of liquid they can freely move here and there. Okay, they are constant in random and rapid motion. We can see example of water. Okay, we can see example of ice. Ice is solid state of water. Then liquid water is the liquid state, and water vapors are the gaseous state. Okay, in case of solid ice, the molecules are not easy, or they are not moving, they are not in random motion. Understand? They are not moving here and there. But if you see liquid state, we can pour liquid. Okay, suppose water we have taken in one glass, we can pour that into another glass. That is flowy. Understand? So molecules of liquid are in state of constant random rapid motion. Okay, then next, number 4, the average kinetic energy of molecule of a liquid is directly proportional to the temperature. So what we can say, kinetic energy of molecule of liquid is directly proportional to the absolute temperature. So these are the 4 characteristic properties of liquid state. First is liquids are made up of molecules. In some cases they are made up of atoms. Second thing is molecules are they are quite close to each other. Third point is molecules of liquid are in state of constant random rapid motion. And number 4 is kinetic energy is directly proportional to absolute temperature. Okay, so these are the 4 characteristics. Now let us see next point. Now next point is properties of liquid. Okay, let us see first property, it is surface tension. Okay, now let us see what is mean by surface tension. So let us see what is mean by surface tension. first see, surface tension is the surface property of liquid. Understand? It is surface property of liquid. Now how it arises? Let us see how this surface tension is arise. Okay. Now see, you can see this is the surface of this liquid. Okay. So the molecules which are present at the surface of this liquid are surface molecules. Okay. And then the molecules which are present inside this liquid are liquid bulk, molecules which are present in liquid bulk. Okay, so A is the molecule of this liquid which is present at surface. Okay, and B is the molecule of that liquid which is present in liquid bulk. Okay, now see what happened. We know there is intermolecular forces of attraction in between two molecules. Okay, suppose these dots which are shown over here, these are molecules. Okay, so if you will see this molecule, this molecule, this molecule, this molecule, they are held together with kind of intermolecular forces of attraction. Okay, so if you will take any two molecule of liquid, there exists intermolecular force of attraction. Understand? Now if you will, first let us take this B molecule. Okay, if you will take this molecule B, it is surrounded with other molecules of same liquid, right? This molecule B is surrounded with number of molecules of the liquid. Okay, so there is a intermolecular force of attraction of intermolecular forces of attraction which are working in between this molecule B and the molecule which is present over here. Molecule B and the molecule which is present over here. Okay, so it is surrounded with other molecules. That means there is a pull of intermolecular forces of attraction from all the sides. Okay, and as the intermolecular forces of attraction are working from all the sides, the means intermolecular forces of attraction, these forces are balanced. Okay, if one molecule is pulling this B from this side, another molecule is pulling this B from this side also. Understand? Okay, if one molecule is pulling this molecule B from upside, another molecule is pulling this molecule from downside also. Okay, so these forces of attraction are balanced in case of B. Okay, but what happen in case of A? This molecule A is present at the surface. Okay, now you can see there are molecules which are present from downside the molecule A. Okay, here one molecule is there, here is there, here is there. That means intermolecular forces of attraction are working from downside only. Okay, so these molecules which are present in liquid bulk are pulling this molecule A towards themselves. Understand? So there is a downward pull. नीचे से ये जो molecules रहेंगे वो उसको नीचे की तरफ खींचेंगे because of intermolecular forces of attraction. Okay, but from upside no molecules are there as it is present at the surface. Understand? So यहाँ पे in this case जो intermolecular forces of attraction है वो balance नहीं है. यहाँ पे balance है. अगर upward pull है, ऊपर से अगर खींच रहे तो नीचे से भी खींच रहे. So there is a balance, but in this case only downward pull is there. Upward pull is not there, and that's why it is imbalanced. Understand? And because of this downward pull, there is a tension or force is there which is acting on this molecule A. Molecule A, or we can say on the surface, all the molecules which are present at the surface. Okay, so that force or that tension is called as surface tension. वो सिर्फ नीचे से खींच रहे इस मॉलिक्यूल को, सो वो नीचे की तरफ खींचा जा रहा है, एंड बिकॉज ऑफ दैट उसके ऊपर एक टेंशन आ रहा है या एक फोर्स आ रहा है, दैट इज कॉल्ड एज सरफेस टेंशन. अंडरस्टैंड? लेट अस सी द प्रॉपर डेफिनेशन ऑफ सरफेस टेंशन. सी, I told you surface tension is a surface property, okay, of liquid which arise due to the existence of intermolecular force of attraction. किस वजह से होता है ये surface tension? Because of intermolecular force of attraction, and it is defined as the force in Newton acting along the surface of liquid at right angle to any line of unit length is called as surface tension. Understand? This surface tension is acting along the surface of liquid only, not inside the liquid. Understood? And that's why it is called as surface tension. And this is because of unbalanced forces of attraction. forces of attraction are working from downside only and not from upside. So these are unbalanced forces of attraction, and due to these unbalanced forces of attraction, this surface tension is created. Okay, so this was the first property of liquid, it is surface tension. Okay, let us see next. Now next point is some important features of surface tension. Okay, important characteristic or features of surface tension. See the first, surface tension is due to intermolecular forces of attraction. This we have studied. Okay, surface tension is created due to the intermolecular forces of attraction present between any two molecules of that particular liquid, and therefore liquids with greater intermolecular forces of attraction have larger value of surface tension. It is obvious. Okay, see, in case of some liquids, intermolecular forces of attraction are strong, and in some liquids intermolecular forces of attraction are weak. Okay, so when intermolecular forces of attraction are strong or greater, in that case, in that liquids, in those liquids, obviously values of surface tension is greater. जहाँ इंटरमोलिकुलर फोर्सेस ऑफ अट्रैक्शन स्ट्रांग रहेंगे, सरफेस टेंशन भी स्ट्रांग रहेगा. वो जब स्ट्रांग रहेंगे फोर्सेस, तो वो डाउनवर्ड पुल का जो स्ट्रेंथ रहेगा वो ज़्यादा रहेगा, जिसकी वजह से सरफेस टेंशन भी, उसके वैल्यू भी ज़्यादा रहेगी. अंडरस्टैंड. नाउ नेक्स्ट पॉइंट बी, एज द टेम्परेचर इंक्रीजेस intermolecular forces of attraction diminish. Okay, and hence surface tension decrease with temperature. Okay, here when the temperature increases, possibility is there. If we take the case of water, okay, liquid water, when temperature will increase, that time liquid water will get converted into vapors, right? So when liquid state is converted into gaseous state, intermolecular forces of attraction becomes weak and sometimes they diminish. मीन्स वो बिल्कुल नहीं रहते, प्रेजेंट ही नहीं रहते, एब्सेंट ही रहते. ओके, सो एज द टेम्परेचर इंक्रीजेस इंटरमोलिकुलर फोर्सेस ऑफ अट्रैक्शन डिमिनिश, एंड व्हेन intermolecular forces of attraction are not present, obviously surface tension will be absent or it will decrease. Okay, intermolecular forces of attraction अगर कम रहेंगे तो surface tension की वैल्यू भी कम रहेंगी. और intermolecular forces of attraction कम कब होगा? जब टेम्परेचर इंक्रीज होगा, इंटरमोलिकुलर फोर्सेस ऑफ अट्रैक्शन भी डिक्रीज हो जाएंगे. In that case surface tension की वैल्यू भी डिक्रीज हो जाएंगी. So it is said that surface tension decreases with temperature. Okay, and surface tension increases with decrease in temperature. Okay, so what we can say, when temperature increases surface tension decreases, and when temperature decreases surface tension increases. Okay, they are inversely proportional to each other. Next, surface tension tends to reduce the surface area of liquid to minimum. It is for this reason that drops of liquid and bubbles of gas in a liquid becomes spherical, the surface area being minimum for a given volume. Understand? What it tends, or what it causes, surface tension tends to reduce the surface area of liquid to minimum. It decreases the surface area of liquid. Okay, next, surface tension is responsible for the rise of liquid in capillary tube, provided the liquid weights the glass. Okay, whenever we try to fill a liquid in capillary tube, you might have seen the capillary tube, that thin tube is there which we use in laboratory, that is called as capillary tube. Okay, so this when we try to fill that capillary tube, okay, so the liquid rises in that capillary tube. And why it is so? It causes, or surface tension is responsible for that process. Okay, because of surface tension the level of liquid in capillary tube rises. Understand? So these are the important features of surface tension. If they are asked in exam, as it is you have to write, as it is you have to recite and write. Now next point is measurement of surface tension by stalagmometer. Okay, so there is an instrument which we use to measure the surface tension and it is called as stalagmometer. So let us see what it is.